Hello one and all. I given two consecutive videos on permutations and combinations. The first part was related to the factorial. The second part was related to the multiplication and addition rule. Now it's the third part about permutation. Now see, the topic is permutation. For 1 is smaller than equal to r is smaller than equal to n, the number of permutations, different ways. The number of permutations means the different ways to take r things from n given things, denoted by npr. The value is factorial n divided by factorial n minus r. How this is possible? So you have to select r things from n given things. 1, 2, 3 r places are there and available things are n. N things available. So the first place can be filled in n ways because we have got n things. The second place 1 less n minus 1, third place n minus 2. So 3 means 2, 1 less. Likewise, rth place can be filled in n minus r minus 1, 1 less r minus 1. So when simplified it becomes r minus 1 plus 1. Now the total number of ways by multiplication rule, this into this into this into this last. So the total number of ways is this. Now let us multiply and divide by. Multiply it by. After this, when we move 1 less, then this is n minus r, and lastly we get 3, 2, 1. The same thing should be divided 3, 2, 1. Now starting from n and ending to 1, this is factorial n. Starting from n minus r ending to 1, this is factorial n minus r. So we have proved this is npr, the value of npr is factorial n upon factorial n minus r. Now, suppose you have to take n things from n given things, then this npr will be factorial n by factorial n minus n. So this is factorial n by factorial 0. So factorial n by 1, this is factorial n. How this is conducted, let us see. So third thing is n minus 2 as usual, and similarly going ahead, the nth thing, the nth place in place of r is n. लास्ट प्लेस को भरने के लिए एक ही आइटम हम लोगों के पास रहेगा, that is one way. n items n place, so last things can be placed in one way. So the total number of ways is n into n minus 1, n minus 2, lastly 1. So starting from n and ending to 1, this is called factorial n. So directly we can write npn is equal to factorial n. So factorial n we are getting. So from this, after knowing npn is equal to factorial n, in this way we can give the proof of a very interesting fact of mathematics, that factorial 0 is equal to 1. How? So this can be proved successfully, since we know that npr is equal to factorial n upon factorial n minus r. So likewise npn is equal to factorial n upon factorial n minus n. But npn is already proved here, factorial n. So this is factorial n is equal to factorial n upon factorial 0. So this is factorial n factorial 0 is equal to factorial n, and hence factorial 0 is equal to factorial n by factorial n cancel, this is 1. Hence factorial 0 is equal to 1. The proof is conducted. Now the related problems on permutations. How we do the problems on permutations? Let us see. The first question, if np4 first, if np4 is equal to 20 np2, 20 np2 find n. We have to find out the value of n. Now applying the formula NPR is equal to factorial n upon factorial n minus r. So this is being used. So we get factorial n upon factorial 4, factorial n minus 4. This is equal to 20. Now NP2 is factorial n. Sorry, this is not simply n minus r, so n minus 4. This is factorial n minus 2. Now this is cancelled with this. And again, as for example, factorial 10 is 10 into 9 into factorial 8. Likewise, factorial n minus 2 is equal to n minus 2. After that, n minus 3, then n minus 4. So we can break this like this. So this implies 1 by factorial n minus 4 is equal to 20 into 1 by n minus 2, n minus 3, factorial n minus 4. This is cancelled. So by cross multiplication, we get n minus 2 into n minus 3 is equal to 20. This is n minus 2 into n minus 3, 20. These are the conjugative terms with more and less. This is bigger, this is smaller. Likewise, 5 into 4 are the conjugative terms. This is big and this is small. So by comparison, we can get n minus 2 is equal to 5 and n minus 3 is equal to 4. So n is equal to 7 and n is equal to 7. So this is our answer. N is 7. So in this way, we can use the formula to do the various problems. The formula will remain on the board. Now moving toward the second question, fourth number. This is fourth from your book. 15 PR is equal to 2730. Find the value of R. Now moving towards the formula, this is factorial 15 by factorial 15 minus R is equal to 2730. Now students, there is a trick. This 2730 is the product of 15 into 14 into 13. This gives 2730. So when from factorial 15, 15, 14 and 13 are taken outside, we are left with factorial 12 by factorial 15 minus R. This is equal to 2730. 2730 is again 15 into 14 into 13. So this will cancel this, and hence factorial 12 is equal to factorial 15 minus R. Now by comparison, 12 is equal to 15 minus R. So R is equal to 3 answer. In this way, we can use the formula to find the value of R. Now another problem, 56P R plus 6 number, 56P R plus 6 is equal to ratio. This is ratio 54P R plus 3. This is given 30800. Ratio 1, find R. Now to find this, we use the same formula. This implies factorial 56 by factorial this minus this, 56 minus R plus 6 divided by 54 upon 54 minus R plus 3. So this is equal to 30800 by 1. Now 56 can be broken as 56 into 55 factorial 54 divided by, this is 56 minus 6 is factorial 50 minus R is equal to, again factorial 54 as usual. This factorial 54 is cancelled with this, and when simplified we get 54 minus 3, 51 minus R. Now 50 minus R. So, and this is division, this is division form. Sorry students, this is in division form. So this is 30800 by 1. Now again, this is 56 into 55 by 50 minus r, factorial 50 minus r, multiply. When 51 minus r is taken outside, there will be 50 minus r divided by factorial 54, and this is 30800 by 1. Now this is cancelled with this 54, cancelled with this 54, cancelled, and this whole will be cancelled by 10 times. So what we are left? 51 minus r is equal to 10. 51 minus r is equal to 10, and hence r is equal to 41 answer. In this way, we have got the value of r. Again, moving towards the next problem. This is 7th number of your book, 7th. NP and prove that NPN is equal to NPN minus 1. So starting from LHS, NPN, we know that factorial n upon factorial n minus n. So this is factorial n upon factorial 0. NPN is factorial n. Now you can directly write NPN is equal to factorial n. Now RHS, NPN minus 1. This is factorial n upon factorial n minus n minus 1. So this n will be cancelled, and this is factorial n by factorial 1, minus minus plus. So this is factorial n by 1, this is factorial n, hence LHS is equal to RHS. And moving towards the next question. Next question number, this is 11, NPR. NPR is equal to n minus 1 PR plus r times n minus 1 P r minus 1. We have to prove this. So starting from RHS, n minus 1 PR plus r times n minus 1 P r minus 1. Now this is according to the formula, factorial n minus 1 divided by factorial n minus 1 minus r plus r times factorial n minus 1 by factorial n minus 1 minus r minus 1. Now this minus 1 minus minus becomes plus, so this will be cancelled. So we get factorial n minus 1. Factorial n minus 1 is taken out common. Factorial n minus 1 is taken common. 1 by factorial n minus r minus 1 plus r by factorial n minus r. Now move ahead. This equal to, you can write equal to. So this is n minus 1. 1 by n minus r minus 1 plus. Now, if n minus r is taken outside, we are left with n minus r minus 1. Again, this is common. So take out common, n minus 1 by n minus r minus 1, 1 by 1 plus, and this is r. R we write r by n minus r. Now let us simplify this. Factorial n minus 1 by factorial n minus r minus 1 plus multiply. The LCM is n minus r, and after that this goes here, n minus r plus r. So r are cancelled. So we are getting n factorial n minus 1 upon. Now this n minus r factorial n minus r minus 1. This is factorial n. Starting from n, this is called factorial n, and this is factorial n minus r. we know that this is an PR. So our proof is conducted. In this way, we can use the. Let us do one more problem. This is the last problem based on this. 15 PR minus 1 if 15 PR minus 1 ratio 16 PR minus 2, this is equal to 3 ratio 4, and the value of R. Again we use the same concept. This implies factorial 15 by factorial 15 minus R. When this is subtracted, it becomes plus 1 divided by factorial 16 by 16 minus R, and when this is subtracted, it becomes plus 2, is equal to 3 by 4. Now this is factorial 15 by factorial 16 minus R divided by factorial 16 by factorial 18 minus R. This is 3 by 4. Now this division becomes multiplication along with 18 minus R outside, 18 minus R, then 17 minus R, then 16 minus R is left. When this is going upside, after that 16, this 16 will come out and 15 is left, and in this is 15 by factorial 16 minus R. This is cancelled with this cancelled with this. And now this is 3 by 4. Now this 4 will cancel this also again. So this is 4 times. So we are left with 18 minus R into 17 minus R is equal to 4 3 are 12. This 12 can be written as 4 into 3. So by comparison we get this, and we are getting R shortly. So 18 minus R is equal to, after that go ahead, this is 4, and 17 minus R is equal to 3. This gives R is equal to 14, and this gives R is equal to 14. So R is equal to 14 is the answer. Thank you very much, students. In the next video I will discuss the problems based on this permutation. Thank you very much.